Okay, let's go talk about how to graph the logarithmic function. I'm going to do all of this, but I'm going to construct it one piece at a time, okay? So going to a new piece of paper. We graphed y equals, let's go do 2 to the x. We graphed that last time, right? We said that our three favorite x values were -1, 0, and 1. Okay, when x was -1, 2 to the -1 was 1/2. 2 to the 0 was 1, and 2 to the 1 was 2. Okay, so when we went and graphed this, we had -1, 1/2, 0, 1, and 1, 2. You agree? Okay, what was our domain? Domain was all reals. Our range was 0 to infinity. Did we include 0? Nope. And we had a horizontal asymptote where? At y equals 0 right here. Okay. Now we're going to go graph the inverse function. To go find the inverse, we started with y equals 2 to the x. You agree? How do you find an inverse function? You swap x's and y's and then solve for y, correct? So we're going to say x equals 2 to the y. Again, this is our function, 2 to the x. We're trying to find the inverse. Okay, we swapped x's and y's. I'm going to have to write it 2 to the y equals x so that I can do this. So I'm going to write log base 2 of x equals y. This is my inverse function, yes? Log base 2 of x. If I start with y equals 2 to the x, my inverse function is y equals log base 2 of x. All right, go back up here. I now want to go graph y equals log base 2 of x. Instead of having three favorite x values, I now have three favorite y values. What are they? -1, 0, and 1. For my y values here, I had 1 over the base, 1, and the base. You agree? Same thing over here. I'm going to have 1 over the base, 1, and the base.
So if it's an inverse, you get it opposite?
All I'm doing is swapping my x's and y's. Instead of having -1, 1/2, I'm going to have -1/2, comma, -1. 1 over the base. Instead of having 0, 1, I have 1, 0. Instead of having 1, 2, I have 2, 1. Go plot those points. 1/2, -1, 1, 0, and 2, 1. So for the red, what is my domain for the red function? 0 to infinity. Go away. There we go. My domain for the red function is 0 to infinity. My range for the red function goes way this way and goes way up that way. All real numbers. Is there a horizontal asymptote for the red?
No, it's a vertical.
There's a vertical where? A vertical asymptote at x equals 0. Now, for inverse functions, the domain of the function is the same as the range of the inverse.
It's the
The range of the function is the same as the domain of the inverse, because all that happened was that you switched the x's and y's.
like a reflection.
So it is symmetric across this line, y equals x. Yes? Okay. Back over to the printout that I gave to you. Did we talk about all of that?
Yeah.
If b is bigger than 1, so back over here on mine, this is for exponential growth. Our base is bigger than 1. What happens to our logarithmic function? Is it always increasing or always decreasing? It's always increasing. When you have the inverse of an exponential growth function, it's a logarithmic function that's always increasing. Let's go graph the example. Go graph y equals log base 3 of x. Okay, what are your 3 favorite y values? -1, 0, and 1. When it's -1, your x value is 1 over the base. What is your base on this example? Base is 3. So you're going to have the point 1/3, comma, -1, 1, 0, and 3, 1. So go graph those 3 points. I have 1/3, -1, 1, 0, and 3, 1. What is the domain for this function? Zero to infinity. What is the range of this function? All real numbers. And there is a vertical asymptote where? At x equals 0. Something I want to point out to find the domain, whatever you're taking the log of, you set that bigger than 0. So over here I'm going to say to find the domain, take this and set it bigger than 0. Got it? Okay, I'm going to jump over to another sheet and go do the same thing, but this time I'm going to do an exponential decay problem. What if you have y equals, say, 1/2 to the x? So this is an exponential decay. How do you know you have exponential decay? The base is between 0 and 1. So let's go do our 3 favorite x's. -1, 0, and 1. Our y values are going to be 1 over the base, so 2, 1, 1/2. Plotting those points, -1, 2, 0, 1, and 1, 1/2. Our exponential decay function looks like this. Okay, our domain, what is it?
The domain is
All real numbers. Our range, 0 to infinity, good. And our horizontal asymptote at y equals 0. Don't just say a 0. You've got to put x or a y in front. Let me know if it's a horizontal or vertical line. Horizontal asymptote at y equals 0. Okay, what is the inverse function of y equal 1/2 to the x?
log to base 1/2.
It's y equal log base 1/2 of x. Our three favorite y values are now -1, 0, and 1. What are our points going to be? Instead of -1, 2, it's going to be 2, 1, which is here. Instead of 0, 1, it's going to be 1, 0, which is 1, 0 is here. And instead of 1, 1/2, it's going to be 1/2, 1. Oh, sorry.
So you put the wrong
Yeah, 2, -1 is down here. Sorry, guys. 1, 0 is here. And 1/2, 1 is here. So this function looks like this. Now, are the red and the blue symmetric across the line? Y equals x.
they're constant.
They are mirror images. This piece here is the mirror image of this. This piece is the mirror image of that. Okay, domain and range of the red. What is the domain of the red? 0 to infinity. The range of the red, all reals. And there is a vertical asymptote where? X equals 0. Now, the red function, is it always increasing or always decreasing? It's always decreasing from left to right. If you have an exponential decay, the inverse, the logarithmic function, is going to be decreasing. If you have exponential growth, the inverse, the logarithmic, is always going to be increasing. It's a lot of information, right? All right, let's go graph y equals log base 1/4 of x. Okay, your three favorite y values, -1, 0, and 1. If y is equal to -1, the x value is 1 over the base, so it's just 4. If y is equal to 0, x is equal to 1. If y is equal to 1, x is equal to 1/4. So if I plot those points, 4, -1, 1, 0, and 1/4, 1, my function looks like this. One more time for a review. The domain, whatever you're taking the log of, so x has to be bigger than 0. My domain will be 0 to infinity. My range will be all reals. And my vertical asymptote will be at x equals 0.